ولا؟
مساء الخير جميعا. السيشن الماضية قبل امبارح كان في برضه على الووتر ادفانس ووتر سوليوشنز، كنت احكي بالعربي. اليوم لانه في عندنا سبيكر from UK I think, so I will switch today to English for the introduction, and then the speaker are free to speak in Arabic or English. First of all, let me introduce myself. I am Tamer Al Asad, Deputy Chief of Party for the Water Governance Activity, responsible for the technical part of the project. And today's session is the third session on advanced water solution, where you can think of technology as IT equipment, but there is many other things under this when you talk about advanced solutions. The National Water Strategy 2023-2040 in Jordan highlighted or addressed the innovation technology in a separated chapter to emphasize on the importance of introducing innovations and technology as a tool to help in resolving the issues around water and wastewater. And that chapter, what's unique about it is also capturing more than one component in one chapter, which is innovations, IT, and linkages with research centers and education, plus private sector. And why all of them together? Because innovation is really linked with of course, universities, research centers, graduate studies, but also linked with private sector. Government, as you know, it's more bureaucratic, it's hard to advance, more stringent, rigid, cannot have the flexibility. So research centers, universities, our private sector are included in that because they are the drivers for innovations and solutions in terms of advanced technologies. And of course, with the IT and technologies is an important part of it. That's why the National Water Strategy combined all of them. Last session speaker, we have 4 different speakers, all of them from private sector. Today's speakers is also from the private sector. And that's clearly why actually the private sector is bringing the new solutions and innovations. Interesting, yesterday we have 4 speakers, 2 speakers addressed the equipments and technology as a solutions. One speaker addressed advanced solutions and design stage, which is very important also. So there is also in a design stage. And one speaker had a solutions on during construction stage. It was a unique also for me personally to learn about it, related to the constructions of Ibn Hamad Dam, where they have a big challenge of having the concrete poured for the dams to reduce its temperatures to 26 degrees in an area that normally during the day it's above 40. So the concrete has to stay below this. So this is very challenging, how you need to come up with the solutions that you have a cooling for tens of hundreds of cubic meters of concrete, which is usually heating. So it's very interesting that advanced water solutions is actually multidisciplinary, integrated in many aspects. We don't think about IT and technology alone. There is a lot of innovations and solutions in the whole process, from design, construction, operation, etc. So today we have a different mix of speakers, but 3 of them are for private sector, and they will addressing, I would say, more into technologies used in the water sector. So their focus is in technologies rather than design and constructions. And we will start with the first speaker, Mr. Paul Harrison from HWM Global, and he is the regional export manager. He will present about smart technology for clean water and wastewater, and he will of course elaborate more what that means. And please welcome him. Thank you. Thank
Thank you, Tamam. You said I am free to speak in Arabic or English. I choose English. Okay. Thank you very much. Hopefully my voice will last 20 minutes for this presentation. But thank you for the opportunity to present today. My name is Paul Harrison. I'm the Regional Manager for H2BM Global. We are a UK manufacturer for a range of products, smart water solutions for clean and wastewater networks. We are part of the Halma Group. Halma is one of the top 100 companies on the London Stock Exchange. There's like 55 companies under the Halma umbrella, and H2BM Global is one of them. So all of our products are built and manufactured in the UK, and then we export all around the world. One of the advantages of being part of a bigger group, it allows us to reinvest profits into R&D, research and development, to introduce new innovations for the water sector. So I'd like to start with this slide about reducing losses in the system, in the network. Okay, so we have like 4 key components. So let's start with active leakage control. What I mean by active leakage control, you have active and passive leakage control. Passive leakage control refers to customer complaints, say I have a leak outside my house, burst pipe, visible leaks. When we talk about active leakage control, many leaks are invisible, so they don't come to the surface. So you need to have good trained technicians with good technology actively looking for leakage in the network. Okay? And then we have, this is directly linked to the repair of the leak. Okay? So it's make sure that the workmanship of the repair is done good and on time, ideally within 48 hours. So the whole buzzword in the leakage market today is trying to reduce the run time of the leak. The earlier we find the leak, the more water we will save. Okay. Then we have infrastructure management. Obviously replacing the pipe, rehabilitation, very expensive to do. But there may be certain parts of Amman, for example, where you're always finding leakages. So it may make sense to replace certain sections of the pipe, okay? Because it's always giving you headache with leakage. So this is something you can consider. Last one, pressure management. If you have a system, normally the relationship between flow and pressure is inverse. So when people are using the water in a 24-hour supply network, the pressure will drop, okay? And at night time, when the flow drops, the pressure will increase. When you have leaks in the system, your volume and the pressure increases, your volume of leakage will increase. So this is exactly what we don't want. So we have some technologies which can help avoid this situation. But if we spend time or effort in any of these 4 components, we will reduce the annual loss of leakage in any system. So typically, the technology that I will be speaking about today can work in open networks. Okay, this means without district meter areas. However, if you do have district meter areas or zones, we call them building blocks or smaller areas, typically between 1,000, 5,000 properties. Okay, so it enables the end customer to monitor each of the DMAs individually and then focus on the district meter areas which are giving you the most headache with regards to leakage. Okay, so here we have an example. We have a DMA. We should always quantify the flow into the zone because this is our starting point. If we find many leaks, for example, we find 100 leaks in 1 month, this is good, my group to the technicians, but it doesn't give you anything concrete. So you should always quantify the flow, but it could be legitimate flow in this zone. So what we need to do next is monitor the behavior of this zone. And we do this by connecting data loggers, telemetry data loggers, pressure and flow, to the bulk meter at the inlet. Okay, this will give you a profile. So it looks something like this. This is like a 24-hour supply network. It looked very different in an intermittent supply network, but typically high demand in the morning, flow drops off, and then at night time, you can deduct the factory usage, okay? So the rest, the night flow, which is currently always running in the background, is your leakage, okay? So if you have 100 DMAs, and then you have maybe 10 of the DMAs with the highest night flows, these are the ones you need to work in. So at least it's giving you critical information where to start. You're not working blind, okay? We call it like a 5-step strategy for finding leakages in the network. Create the DMA, which I believe in Jordan they're quite advanced. Many cities are advanced in this step, so that's a good start. Then identify the leakage area based on your DMAs. Then we need to find the leaks in the network, okay? Confirm the leak and then repair, okay? Most of the technology that I'll be talking about for leak detection today is acoustic technology, okay? So once the dig and repair happens, the final stage, it's important that we revisit this site, because if you eliminate this leak, the technology is always picking up the leak with the loudest intensity, okay? But there may be a second leakage on that pipe. So you always need to revisit that section just to double check that you have maybe a second leak. And the second leak will be larger volume because it is quieter than the smaller leak. It's based on sound, yeah? So having permanent deployment of technology, of sensors, helps you with finding leaks, reducing the runtime of leak very quickly. So finding their leaks when they're very young, okay? So just take you through some of the technologies that we have. So for the DMAs, for the monitoring, we have a range of telemetry data loggers. We have portable loggers, but you have to go to site, program the logger, download the data maybe in 3-4 months, but you could be missing critical information. The market has moved to more telemetry kind of online systems that they're sending data 3 times per day, 5-year battery life. These loggers can be installed in chambers, IP68 compliant, so that means if there's a flood in the chamber, the logger is protected and can still send data, okay? And then you have alarm thresholds in the software end. So if, for example, you're interested in the night flow and the flow goes from 2 liters per second to 5, you set the alarm. Then as soon as it hits this 5 liters per second threshold, it sends an alarm real time to the portal, which is installed on the local server. And then from there, it sends alarms to the technicians via email or via WhatsApp. So they have the GPS location of their phone, the flow reading, the pressure reading, so they can go directly to site and find out what's happened, okay? So they don't have to wait until the data comes in. So this is one of the innovations we've made with the loggers. It has, typically, this is a flow graph giving you the flow readings and an average flow over a period of time, okay? But it's done on averaging. And what we're interested in is night flow here. But what's also interesting, we can switch on what we call a fast secondary channel, which is inbuilt into the logger, which is very fast recording. So maybe in this particular case, we would think 0.3 liters per second, minimum night flow. I will send my leakage detection people to the site to go find some of the leaks. But we switched on the fast channel logging, and we established in the same area, same location, same graph, but faster sampling, we noticed that some of the flow readings hit 0. So by definition, if the flow ever hits 0 during a sample period, you can never have any leakage because the leakage is always running in the background. So you would have sent technicians to site, but by switching on the fast innovation channel, channel logging, you then can discard this site as not necessary, okay? So this is just superimposed on the same graph. You have the average, and then you have the more instantaneous reading. So that's useful. Also in the logger for pressure transients, which pressure transients are, we call them either water hammer, can happen very close to like a pumping station. So they happen very quickly, and a standard pressure logger will not pick up these water hammers. So you need very fast sampling, which typically can be 25 samples a second or 100 samples a second. Then you will see these spikes here, which can do huge damage to the pipes, can burst the pipes, but you don't know they're there. So you will put the logger there, you switch on the transient logging, and then you can maybe reduce the speed of the pump to make sure these water hammer events are reduced. We have a hosting platform, okay, which can be installed locally on the local server or cloud. So this is available for all our suite of products for leak detection, for data loggers, and for pressure management. So once you install the technology, we call it fit and forget technology. So that means that any changes you want to make to the logging, recording time, you can do it remotely. So you don't have to send people back to site, because it's using basically 4G or NB-IoT technology, and the communication is two-way. Okay. So pressure management, as I explained, pressure management has an immediate impact on the volume of leakage in your system. Our pressure controllers work with existing pressure reducing valves which are installed in the network. So the advantage of this product: 5-year battery life, autonomous, 4G technology, 0.1% pressure transducers for accuracy, and again, it's for control of the PRV. So here's a typical installation. So the pressure reducing valve is installed because the customer is concerned about high pressures. So they install the PRV. The advantage is to reduce the pressure for this PMZ, for this pressure zone. But what you have to do, you see the pilots, they have to mechanically fit the pilot and the screw, and they have to fit a setting, make a setting that satisfies maximum demand, okay, which is during the day. But what happens at night when the flow drops off? The setting of the PRV downstream is the same. So the pressure will still be high, okay? Less than before the installation of the PRV, but still more than is required. So this is where we come in as a manufacturer of the pressure reducing controller, and we use basically a hydraulic actuator which works in conjunction with the existing pressure reducing valve pilot, all brands of PRVs. So we are generic, we will work with any. We basically have our hydraulic actuator, which is the same thread size as the pilot. We set maximum and minimum pressure, so it can never go beyond these 2 points. And then we have different ways of working with the system. We either work via time, so typically maybe 11 p.m. we drop the pressure till 5 a.m. in the morning when people get up for work, or you work flow modulated, so you will have a flow meter in the chamber with a cable to the central unit. So as soon as the flow increases, the pressure will increase, and when the flow drops at night, the pressure will drop and the valve will close, okay? Or we work with what we call a closed loop learning system, which works via the critical point, which is either the furthest point away of the pressure zone or the highest point. So they are a paying customer, so we have to make sure they always get the required pressure day and night at all times. They are kind of our reference point, okay? And they are feeding back, we're feeding back the critical point data to the server every 15 minutes, and then it sends commands and tables back to the chamber, and it will open and close the valve accordingly to keep the critical point at a minimum pressure. So all battery operated, all IP68 so no problem if the chamber is flooded. The only thing that needs to be above the water is the GSM antenna. If this GSM antenna is below water, then maybe it will not send the data. But if for one day it misses the data, it will send the data the next day. But it also has a backup table in the controller which will automatically back up the data and control the valve in case of non-communication. So this is the typical installation on any PRV. And then this is our standard PRV installation. So you have standard fixed outlet pressure, and then your critical point is changing. So you can see at the night time your pressure will be high. So this will increase the volume of leakage. So we want to change this behavior. We will install our controller at the PRV, and we are now doing the opposite, yeah? So we are controlling the valve, and now we have a very low minimum pressure at the critical point, okay? So this makes sure that this paying customer is always getting the minimum required pressure 24/7, okay? The advantages of pressure management. So apart from saving of the water, reducing the volume of your leakage, okay, the pipes will last longer because there's less stress on the pipe. The pressure is smoother system, so less changes, less variations, so the pipes will last longer. Better customer service, and the volume of leakage lost will be reduced. Your leakage is still running, but the volume of leakage is less, okay? And here you can just see, with leak detection, it takes time to recover the investment, return on investment. With pressure management, from one day to the next, you can see the return. Here is before installation of the controller, fixed outlet pressure. The green is the critical point, blue is the flow, and you see the night flow here. This is the night line. Then we control, and you can see there is a drop in the minimum light flow. This is our saving of water. So we can immediately calculate in Jordanian dinar, this is our saving in water. So we can go to management and say, this is how much water we've saved, and they say, okay, good, we can replicate this in other areas, okay? But the leaks are still running, okay? So now we have to find the leaks. How do we find the leaks, okay? I think it's time for my voice a bit of water. Everyone can still hear me okay, yeah? Okay. So leak detection, we're the world leader in this field, finding leaks. We need to know where to go. This is the final stage, the leak ground microphone. This is the final confirmation stage. Comes with the headphones, elephant foot filters. So depending on the pipe material you're working, if you're working on a plastic pipe, has plastic filter settings, metallic filter settings. It also comes complete with an app, okay? You can load the app on the phone, you can pair it with the central unit. The advantage of that is you can send audio files from the leak site, okay? If you have, for example, a leak detection technician, he's new to the job, okay? He's had a few weeks or whatever, some training, and he's not sure where the leak is, whether it's this here, this location, or here. He can take a file, he can then send it via the app, okay? Via email, or if they have the software installed on the server, the leakage management guru technician can listen from the office and give his recommendation of where the leak is and feedback to the technician. This is one advantage. The other one is also it builds up a history of the network, okay? So you will have, you found a leak, but also you can have the sound file on the software portal, okay? And then you can hear a noise, leak noise on a plastic pipe, 100 millimeter. The noise will be different to a ductile iron leakage on a 200 millimeter. So it builds up a profile, also tells you how many leaks you've been finding in a certain period of time. So it may say you found 12 leaks on the same section of pipe. I think it's time to replace the pipe because you have this documentation and this history, okay? So that's the confirmation. Correlation is to pinpoint. So this technology goes onto valve fittings. So typically every 250 meters, you put a sensor, you put in the diameter, the distance between the two, the material, and it does a correlation. Basically, it's picking up the time difference of the leak arriving at one sensor compared to the next. So it's using time delay. And then it will give you a position of the leak, okay, which will be basically a graph with a peak in a fixed position, because believe it or not, the leak doesn't repair itself and it never moves, okay? It's always there. So if it keeps moving, then it's consumption. It's not leakage. The leakage always stays in the same place. So let's move on to the acoustic technology, because this has really changed the market for water utilities, okay? Because this can work in open networks, but also in hotspot DMAs, okay? So we won the Queen's Award for Innovation back in 2017, which is a prestigious award for manufacturers. So basically inside the logger, it has a magnet, it has a SIM card, it has a leak sensor and antenna. So it will log between 2 and 4, and then at 4 a.m. finishes recording, and it's looking or listening for consistency of noise, constant noise over time, okay? And then it will also make a 15-second recording and then send this data to the online server, okay? And then basically you will get a list of priorities of where your leakage is, okay? Here, I don't know if it will work, but if you have a sound file, you can listen and you can hear a clear leak noise. How long I have, like 5 minutes?
Probably this.
4. Okay, let's call it 4. So there's a typical leak peak, okay? Then we have large transmission lines, so larger diameter mains. We pick up noise traveling through the water. So the first technology was across the pipe. This one is in the water column for large transmission mains or plastic pipes. We've also introduced AI, artificial intelligence now, with our noise sensors, so using like a spectrogram. So now this really reduces the number of false positives, because leakage is not the only constant noise. You have other noises like PRV noise, pumps, transformers, and we can reduce the number of false positives now by having AI inbuilt. Final few slides now, just on wastewater networks, in case anyone is involved in wastewater. Wastewater is now huge investment in wastewater networks. They're really concerned about the environment and pollution and spillages of the wastewater network, okay? So we have a range of products, again, battery operated, 5-year battery operated, and they are monitoring these manholes in the sewage network, okay? So what we're trying to do is to avoid the spillage, okay? So this is radar technology, very useful and precision with temperature changes and under foam, okay? So then it's always sending the level of the chamber. So maybe there's a blockage downstream, and then the chamber is flooding, you will get an alarm, and you can go to site to make preventative measures to prevent the overflow from happening and this spillage. UK companies are hit with huge fines for these spillages, but around the world, especially around the Gulf, they're investing heavily in this kind of technology to look at their network and permanently monitor the wastewater network. Wastewater parameters, water quality, different parameters we can monitor, all in battery operated system, 5 years. Last slide, this was for level monitoring as well. Digital sensor connected to logger, very low cost, installed in manholes. Doesn't give you the exact level of the chamber, but it will tell you when the water has hit the sensor. It's like has 3 gradients, and then from there it sends alarm, and then you can go to site and then sort out the blockage. Okay, so very, very quick overview of our system, hopefully helpful. Just to finish on, we do have a stand in A1, Atrium Global is proud that our representative for Jordan is Retouch Technology, Technical Services. We have many projects we've executed in Jordan and throughout the Gulf. If you have time before you leave the conference, we'll be happy to discuss in more detail you at A1. Okay, that's me done.
Thank you, Paul. I just have quick follow-up questions because I personally work on some of the technologies you already presented in Amman as a pilot on revenue management. And it's mainly about the pressure management with the sensors and data loggers and pressure control valves. One of the key challenges, which is in Jordan, another scarce country of water resources, is the intermittent water supply. The technology you presented, particularly for pressure for revenue management, works good and perfectly under continuous supply. Can you highlight a little bit, Shit, if there is more advancement handling the intermittent water supply issue? Because it's really another dilemma, but could be briefly. Because this is an issue.
I think it's an important point. I think.
Can we have the mic? Should have done it. I'm just going.
Yeah, very valid. I was some of the graphs I was showing and looking at 24-hour supply networks. I attended a conference back in 2019 in Uganda about intermittent water supply. It was an intermittent water supply conference, and all the experts in the industry were there. Okay, and the key takeaway from the event was you do not accept intermittent supply. This is point number one. Okay. Mentality change, switch, okay? And then you need to, rather than say, okay, if we put more water into the system, the pipes are gonna be leaking. No, you need to break down the system into zones and pressurize zone by zone, work on a zone, pressure a zone, give it 24/7 supply, okay? You can have pressure management in there as well to reduce pressures. Then you can find leaks. Then you can save water in this zone. So you've saved water, and then you move to the second zone. It's a process which takes time, needs a lot of patience, but many, many good results can be achieved over time. But you are correct, the technology does work better in 24/7 supply networks. But I think this is the strategy we need to follow. That's okay.
Yeah, actually there is a lot to elaborate on this because we did some solutions to overcome these situations. But that's a different discussion. So let me welcome the second speaker, Mohammed Abu Shanab from Well Company. He's the Jordan country manager, and he will present on wastewater collections and lifting station, new technology. Please.
Good afternoon, everyone. It's good to be here and have discussions with you during the 7th Arab Water Week. It's been really interesting for me to see new faces from the Arab countries coming into Jordan. So welcome to Jordan, and it was really a good chance to meet you all and have discussions about sustainability topics and also about people who are in the fight of water scarcity, energy savings, and food security. So I will start with a point where my fellow he has ended, like the wastewater, the dirty work, where I'm talking here about wastewater collection and transport system. So we call it in Arabic بالعامية محطات رفع for the collection of wastewater, sewage, and transport it over long distances to the treatment plant, or sometimes lifting from a station to another station, because we have a problem of altitude elevation from the collection points. So it is something like this. Some people in countries they use the pressurized networks where each station collect wastewater and pump it to the next station, and then there will be a main station to drain out to the treatment plant for treatment, and then reuse of the water. Or it could be by gravity, and this is the most convenient option. So you don't pay energy consumption, or you don't pay for electricity or pumping when you are transporting the wastewater. But unluckily, this is not the case in all the countries and situations where you have different altitude. People are living in sometimes valleys, and the wastewater treatment is not on the same levels or below. Maybe on the higher elevations, we have to pump it maybe one time or in series with different pump stations. So today I will be just giving you shortcuts about us quickly, and application of WELO solid separation system, which is used in the collection and transport of wastewater. What is it exactly? Functionality, configuration, and the range quickly, and your advantages. So to start about WELO. WELO is a German company and one of the world's leading premium providers of pumps and pump systems for the building services, water management, and industrial application. We move water in an innovative, efficient, and climate-friendly manner. So we work hand in hand with our customers, okay, to really understand their pain points and work in each specific case and provide them a custom tolerated solution which meets their requirements and overcome the challenges. So we moved from improving hydraulic efficiency, overall efficiency and reliability of the system, but now recently we are more in digital approach where those pumps are smart enough to monitor itself, to protect itself from blockages sometimes in wastewater, and even control other pumps. It is smart and digital. It can be also connected with the DDI, what we call digital data, let's say interface, okay, to a dashboard where you can see all the operating parameters, temperatures of the bearing, the winding, the vibration, and 3-axis. So you can have really a good plans for preventive maintenance or to analyze what is exactly going with your pumps. So this is the application that we are active in. The company started in 1972, so we are more than 150 years old company, providing for different application. Let's say we work on the complete entire water cycle from raw water extraction, let's say water treatment, transporting the water in good quantity and quality to the consumers, and we have then the products inside the buildings or the complex, what you have, and then collection of wastewater, transport to the treatment plant. In the treatment plants, we offer also a wide range of the product which are used from the primary to the reuse of the water at the end of the process. So we have 16 main production sites around the world and 70 subsidiaries and sales offices in more than 50 countries. So the company is a German company, started in Germany. We have now 3 plants there, but we also are having production plants in USA, in China, in India. We have in Italy, France, 2 big plants there as well. In Turkey, UAE, we have mainly assembly plants. So we build the pumps in Europe or in, for example, India, China, and then we assemble and package the system with the controllers and all and deliver the solution, which meets a specific region's requirement. Because in UAE, for example, high temperature, ambient temperature, whatsoever, so this is not available in Europe. Before, you were sending the requirement, they take lots of time, very much expensive. So we customize the solutions as per the region, and this is what we call region for region approach. This is why you can find us everywhere. So, application, why MO solid separation system? Like some glance about the history, we used to transport water usually by gravity through, let's say, channels or canals. Whenever we have the luxury to, we have different in the altitude, as I said before. And whenever we don't have, we use trucks to transport this water from a place like a collection tank of the sewage to water bodies before all time. They're still not in many countries, but still there are some doing this. But nowadays everyone is using lifting stations, and we have a different configuration. So the conventional conventional system, you usually find the submersible pump submerged in the sump tank or dry nose code. Submersible pump is always preferred. Sometimes it is actually a low investment. You have already the pump installed inside and you don't need say special cooling for the motors or whatsoever. And the second thing, when you have the pump dry, so you can see the pump outside the pit for the operation lifetime of the pump. Also, you can do the measurement of vibration whatsoever, which is not available in the submersible installation. But usually you find lots of challenges in this application, where you can, let's say, you don't expect, especially in lifting station, the content, the solid matter inside the medium. So you can find rags, papers, and diapers, everything you can imagine counted. And there is also increasing solid matter in the wastewater. Pipe clogging, you have increased number of several calls and service cleaning of those. Plus, yeah, it's not hygienic, also smells. So our solution, solid separation, it works well. It's a complete turnkey solution, okay? So the system is, let's say, plug and play, turnkey solution for collection and disposal of the wastewater. It comes with all the, let's say, fittings and valves all over, pumps, collection tank, control panel, and to be fully in operation. So in the inlet, you have a distribution chamber. This is the transparent chamber where the inflow is divided into two solid separation tanks. In this two solid separation tank, the solids or the particles will be retained inside by means of screen. And then only screen solid will pass through the pumps to the collection tank. Okay? And then when the tank level reaches a specific limit, the pump will stop and it will take a screen solid, pump it directly into the solid separation tank, and then it flush all the solids retained inside directly to the discharge. So to make it more, I'm switching around, so should I point here? So just to break it, okay, so that one is, let's say, the demo or the small size of configuration which can be used in residential, commercial application, and small capacity of lifting stations. But we have also different configuration which I will show you. Here is a cross-sectional cut. The inflow will come. By screen, all the solid matter will be retained in the solid separation tank. Then screen sewage will pass through the pump to the collection tank. By this, you can use actually a small wall passage pumps, because the solids are not passing through the pump or not even reaching the collection tank. So less sedimentation and settlement inside the tank, less cleaning of the collection tank, and less plugging for the pump. And whenever you are able to reduce the ball passage of the pump, so you can go with a different type of impellers that use, let's say, a small ball passage and enclose the flow in an efficient way. So the pumps usually that has a smaller ball passage, it has also a high hydraulic efficiency. And this is the economical advantage by selecting also more efficient pump to pump the sewage. Because in sewage application, most of the people, they look for how much this pump is non-clogged, because you need to pass the solids. You don't need plugging. So I go for a big ball passage, 100 millimeter ball passage of the pump, even if the efficiency drop or vortex open impeller to 60 or 70%. But with this system, you can go with even more enclosed impellers and increase the efficiency from 60 to 70, 75, or above 75, let's say. So to keep it, and also a bigger configuration of the FJ system. This is also the same principle, but it is all put together. Okay, so this is the inflow, number one, distribution chamber. Then the flow is distributed to two solid separation tanks. This pump is in filling process, while this pump is in pumping process. So let us imagine that now this is a filling. The water will come from here, will reach this limit. and inside the collection tank as well. So these both tanks are full of water and big shuttle walls, two walls will close the inflow for just milliseconds. One pump will start, let's take this one, and take the screen sewage from here, flush the tank directly to the discharge, and then the second pump is intaking. This is only in milliseconds, so it's a continuous inflow. To also have it in more clear way, I have a demo video, maybe you can turn it on. To walk on it. Yeah, so the process will start from the inlet. I hope it's working. Yeah, so the sewage is flowing from the inlet, distributed in two solid separation tank, then the shutter balls raise to close the inflow for seconds. Screen sewage are passing through the pump and filling the main collection tank. This is only a stop of milliseconds. Now the pump will sense that this is a high level, a pump will start, that pump, flush the solid separation tank directly to the discharge. And this is continuous intake. The second pump is intake now, filling the tank. Now in each filling process, the air is pressed out from the collection tank through a vent pipe. So it's also a gas tight. There will be no smell in the pump station of sewage whatsoever. So it's enclosed, the gas is enclosed inside and is pressed out from the collection tank directly to the vent pipe, or you can sometimes, if it's a residential area, you can install odor control unit or something for the treatment of the air. So the economical advantage, as I said, you can select low ball passage pumps or small ball passage, high efficiency pump in the sewage application. Even if you have a particle size of 100 millimeter, you can use a pump which use only, let's say, 80 millimeter ball passage or 50 millimeter ball passage. Yeah, and then you can save more. So this is the FJ design of the solid separation system. Configuration and range quickly. We have the pumps can be installed in an existing shaft, okay, or in a new PEHD shaft. So we fabricate as well the PEHD, polyethylene high density shafts, or inside buildings. So it looks like this on different application, because this is like a quite customized system. Depends on the installation and the space available. So you have for ground installation or shaft installation. So it comes with all the accessories, the collection tank, the ladders. We just have to dig the hole in and we can do the remaining job. And that system actually is the biggest that we have produced, of 1,200 cubic meter per hour inflow to the station. So we usually ask for the inflow, we ask for the discharge profile of the pipe, how much is the static head, how much is the dynamic, and then we select the collection tank capacity, we select the pumps suitable for this, and we give you the design drawing to prepare your sample. So your advantages: maximize the operational reliability, and then we have the best material selection for this application, save energy consumption, and let's say the product is connectivity and how much it is digital and can be monitored on dashboards and all. So about the material for the collection, wastewater collection pump stations, you usually see concretes or you see stainless steel. Now you can see some pictures here for steel pipes or concrete channels, stainless steel shafts used in sewage application after number of years, and how much this aggressive water or the sewage will impact it. Even if it's a stainless steel, on the anchorage you can find like some corrosion there, and there is no passive trade of having it, even if it's a bigger investment. We use a polyethylene high density. This is a chart from University of Darmstadt, where you can see different material and the life cycle cost with, let's say, test cycles with the average in millimeter, comparing AC pipes, GRP pipe, concrete pipes, clay pipes, PVC pipes, and the PE. polyethylene high density. We can see like it has the lowest pressure in millimeter compared to the other materials. And it is also having a very lightweight. Weldability is also possible. Wear resistance, you have easy transport, and many other advantages from material point of view. This is an example of Lauter, Germany pump station, where we have replaced an existing pump station from, let's say we were having a 110 kilowatt pump with a 100 millimeter wall passage, because as I said, a bigger wall passage, you need let's say semi-open impeller or open impeller, non-clog single channel to pass these solids or particle size. When you go with smaller bore passage, at 80 millimeter, you can go to 98 kilowatts, as I said here. And we have fixed, let's say, a multi-channel impeller with the smallest bore passage of 50 millimeter, and then it reduced the power to 87 kilowatts. So it allows us to go with a more enclosed design of the impeller because the solids will not pass through. And this is the calculation, even let's say, of 10 years ROI, but this is based on the energy consumption at that time. I think it's much less now of the energy consumption because now the rate is much higher. Some success story quickly in Dubai. I personally worked on this project in metro station with RTA, Road and Transport Authority in Dubai, where they are facing, especially in the underground, let's say metro stations, a big challenge of the clogging inside the pipes for the pumps. They were investing a lot in the cleaning. I think the operator there were Serco. They are also well-known company for the operation. And this was a problem that they cannot actually solve, even with macerators. Because macerators are used sometimes in sewage to cut it to fine particles which the pump can take, but depends on the content of the solids. So, for example, the tissues or papers, rags, this will all, let's say, accumulate inside the pump and the pipes. And after sometimes it creates, let's say, a tissue wall, what it's called. And then it will also clog. So that solution was also, let's say, explored by them. So based on the available space, even it was very challenging to get the pump inside the power water plant room because there was a very small access in the metro station to the, let's say, pump station down. And you can see here some pictures from the flooding. I finished. Yeah. So we have customized the system with a collection tank in the rectangular shape. You can see the shape is actually fitting the accessibility and the space available in the pump station. We have installed a dry install pump there with the solid separation system, and this is the, let's say, revenue was actually in less than 2 years because they were paying a lot for the cleaning and all shutdown of the station, etc. This system can be also monitored by smart gateway and our smart controllers to the cloud, and you can stay connected with the dashboard or even a smartphone using the Willow Assist app. So I have finished just one video of 30 seconds, I believe, to show you the whole process demonstrated in a nice way, more than explanation.
You should have put that in the beginning.
Yeah. But it's also, I should take like, I have like 20 minutes, I should spend sharing. So yeah.
Is one pump standby and the other in operation, or the two they
No, they don't operate together. No,
together?
no, usually they don't operate. It's not operating together. It's one duty, one standby.
One standby.
Yes. So this is like a replacement of an old system. You can turn on the voice if it's possible for you. It's more interesting. Sound. system in different configuration, the most compact version of this solution. Then discharge directly. And this is the means of filter. You can see the screens now in more details. Lab disk. So all the solid metal are retained in the tank and then into the discharge directly without going through the pump or the main collection tank. And then you have a very nice and clean wastewater collection and pumping station. Yeah, as I said, also odor control unit is there, or activated carbon filters can be on the vent pipe or the air contained in the collection tank. And that is all. Thank you very much for your time.
Thank you, Muhammad. I have a quick couple of questions because what you presented is interesting, at least from my side. It's always a challenge when you have advances and technologies, I would say, is how you can make sure that you can sustain these technologies, because if you cannot sustain or maintain, it's become obsolete, and utilizations. In your case, I have a question on the utilization and on the sustainability or maintaining the system. You mentioned, first of all, that there's a discharge of the waste. You did mention what we will do with the discharge, because this is important, and how much could be the ratio. Yes, it depends on the solid percentages, but how much could be from that? And this is like another issue that we have to handle to maintain the system. Plus, the system is a lot more complicated than conventional. It saves costs and of course, but maintaining it, how it is difficult compared with the conventional system. Just in 1 minute, please.
So actually what the system does, it is just a separation of the particles, okay, that it is inside the same medium. I'm telling, like, we have 2 meter cubic of sewage or wastewater flowing into the system. And this 2 meter cubic will contain some particles. So those particles are the same. It's only retained in the tank for a purpose, that it's not passing through the pump and not passing and not going to the collection tank, which reduces like the ball passage and the collection tank cleaning process. But at the end of the day, when it's pumped back to the system, it is the same water which was already coming to the network, 2 meter cubic of wastewater with the content. The whole idea is to just take the economical advantage of the pump station, reducing the ball passage, and also the service and clogging. But the wastewater, anyhow, it's not a treatment of wastewater. It's just a collection and transport. And this is like how we do it in the most reliable and efficient way, by reducing clogging and maintenance costs inside the pump or the collection tank, and also get also good efficiency of having a lower ball passage pumps. But it's the same water. So when these solids are pumped, it is pumped to the treatment plant, where there is screens and there is also all of this treatment kind of process there to purify the water and reuse it. Yeah, I hope I answered my question.
So your system,
Yeah.
the discharge tank will be used to dispose of this later on through.
It is the same wastewater. So
Yeah, I know, but
yeah,
it has to be
exactly.
it has to be maintained, because if you don't maintain that.
No, the flushing tank
the
itself.
flushing tank-
No, it is. So for example, this 2 meter cubic comes in
Yep.
with the solids, and it goes out after, let's say, 3 hours or 1 hour or even 30 minutes.
So the solids where
Will
go?
not be returned. It will not be kept inside the tanks. It will be flushed. This is what you
Where
saw.
it will be flushed? To the system again?
As you saw in the video,
Static.
as you saw in the video, the tank separates, the solid separation tank separates the solids and keep it there. Now, when the pump stops, it pushes the water, it flushes the tank,
Ah.
and then directly go to the discharge. So the solids are not kept inside the tank and it is not cleaned or you have to clean it manually. Goes directly to the discharge line. Yeah.
But that-
So
that's what
it's
it-
just
You
like
mentioned discharge, but it's not taking
no to the discharge line to the treatment plant. So the solids definitely is not kept in the system.
Ah, I
In
see.
every filling process, which I mean in each discharge process, the tanks are flushed, so they are kept clean. If the system is running for 3 years, and then you open the solid separation tank,
Okay.
you'll find it
So
clean.
that's it here.
Yeah.
Let's make
You
this-
mean this ball, we will close the inlet and the
And then,
all
yeah,
the
this is the
pipes
reason
will
why
be
the ball
flushed
closes the
inside
inflow,
of the
because when it closes, the pump will push the water inside and it will be pressurized, so completely flushed by a pump, directly to this discharge line, which is
Yes,
down.
clear, I
See,
yeah.
understand.
Now it's clear, because
Now
it
it's
was not.
Yeah. Any other questions?
That's make it easy to maintain, because that was the challenge.
Definitely, yeah.
Okay,
Okay, great. Any other questions?
maybe after that.
Okay, yeah,
Thank you.
thank you.
Now our last speaker will be Ms. Adele Khalifa from Sparta company. She is the regional manager of the company, and she will present about water and wastewater treatment technology. Please welcome Adele.
Thank you, dear. My name is Adla Khalifa, not Adele.
Adla.
Adele
I'm sorry.
Songal. Okay. Good afternoon, everyone. I'm the regional manager of Sparta Company. In Sparta Water Technologies and Engineering Services, we focus on sustainable and efficient solutions for water and wastewater systems across the region. It's a real pleasure to be here today at the Arab Water Week conference among such passionate and forward-thinking professionals. In our work, we've seen how the right combination of innovation, smart design, and engineering expertise can truly transform water systems and make a positive impact on both people and the environment. This conference reminds us that solving water challenges is not a solo mission. It takes collaboration between all of us. It takes collaboration between engineers, innovators, and decision makers. All of us working together to secure a better water future. Actually, I'm excited to connect with all of you, to learn from the inspiring work across the water sector. Before I conclude, I would like to take a moment to express our gratitude to the organizer for this exceptional event. As a token of appreciation, Sparta is honored to present a special gift to the Dr. Khaldoun, but he's not here. Okay, unfortunately, we can give it to him later. For their outstanding efforts and making this conference a great success. I'm truly grateful to the opportunity to speak here today, and thank you for having me. أكثر كلمة ممكن تسمعوها.
ما هو الكلام أقل وزن.
Thank you, Adla. I apologize for misspelling your name. I'm always not good in the names. I know your presentation was very short. If you want to highlight a key innovations that Sparta has in the water and wastewater technology, what you would like to maybe mention here? For the
Actually, we do a lot of projects in MENA region.
Yeah, you can here. Have more time. Still have time.
Actually, we do a lot of projects in MENA region, in Iraq, Qatar, Saudi. in water and wastewater systems and industrial water also. Also, we work with the government in Iraq, and we have a project in industrial water. بالindustrial it means like المسالخ، المذابح، هاي الأشياء اللي فيها بيكون ملوثات كتير مثل البلاد بيكون فيها يعني كيميكال والاندستريال بالضبط. بالاضافه لانه احنا بنقدم السبير بارتس، الممبرينز، المضخات، وفي كمان الكيميكالز لمحطات الووتر والويست ووتر. وات ايلس؟ انا ما بحب اطول كثير وسريع سريع. We based in Jordan and Turkey, in Sparta in Turkey.
You have any project here in Jordan?
Of course we have with الطاحونة، دجاج الطاحونة، المراعي. عملنا بروجكتس كثير هون. كمان اشتغلنا مع مياه اليرموك ومياه هنا as a subcontractor. يعني لأنه احنا ما بنشتغل دايركت، ما بنقدم عطائية عن طريق المين كونتراكتور. بالإضافة لأكثر مشاريعنا بالعراق وتركيا والسعودية حاليا. Dr. Khaldun is coming. Okay.
I'm sorry, but I have to check something and do. My colleagues need something. That's why I returned.
مطلوب دكتور خلدون.
مطلوب حاجة قليلة.
تفضل نعطوك هدية. Appreciation.
It's a masterpiece from Jordan. يعني. It's a traditional
زي.
Thank you, ma'am. Okay, thank you.
Thank you.
شكرا ست عادلة. And many thanks for our issues. I think we have still some time for additional questions in addition to mine. So if anybody has some questions here,
I
please.
have one question for Mr. Paul.
Paul.
About the correlator you mentioned. The correlator.
The mic, please.
I would like to ask a question about the correlator you mentioned in your presentation. I would like to ask about the maximum distance that is available between the two sensors. Maximum distance between the two sensors for the correlator, please.
We have two options.
Everything else.
Two options for the correlator. We have the standard sensors, which pick up the mechanical vibration of the leak across the wall of the pipe. Okay, so on metallic pipe correlation, you're typically looking about 300 meters between each sensor, and then on plastic pipe, no more than 100 meters, because plastic pipe, the leak noise is quieter, low frequency, so it disappears over shorter distance. So the two sensors have to listen for the leak. If one listens and one doesn't, you have no result. Okay, so this is basically the principle. So 100 meters on plastic, 300 on metallic. On large transmission mains, you can go up to, like, because you're using wet fittings, so hydrophones picking the noise in the water, you can go up to about 1 kilometer between each sensor. Hydrophone, but it's a hydrophone sensor which is picking up the noise in the water, so it doesn't pick up the noise on the column of the wall of the pipe, so longer distances. So they're basically guesstimates. The more pressure you have, the better quality of leak noise.
Thank you, Paul.
Thank you. First of all, I would like to thank all the participants, the speakers, the exhibitors for joining us. It was significant improvement in our this version of the Arab Water Week. I know Willow for the last 15 years. We did together energy efficiency. Allow me, please. Omar. Excuse me. in energy efficiency in Salt, in Wadi, Unwala, and also we support the new SMEs, the new industry. That's why I welcome you, Adla, and hopefully that will be serving all the exhibitors. Don't hesitate anytime to contact us, that we can connect you to any of our members in the region. Always there is new technologies, and if we don't follow up what is going on in the world, I think we'll be back. Welcome everybody and thank you.
شكرا مهندس خلدون. أي حدا عنده أي additional questions للسبيكرز قبل ما نختم؟ Yeah, please.
Thank you very much for your presentation. My question goes to Engineer Muhammad from Gillo. First, it's a small comment. Wastewater, you mentioned as a dirty word, but now in the word called as a brown gold, because there is a lot of, I would say, outcomes of the treated wastewater and sludge. So it's just for the figure of speech. And my question, does your system support the industrial implication? Since in some cases the high acidity of chemicals that come in the wastewater, especially in the industrial zones, that would affect not only the pump but it also affect the storage tank. And also the other question would be, since you are pumping, flushing the tank back to the system, right? If I understand you correctly. So basically it's the same wastewater, but the system is only to give more life for the pumping station. That's it.
I will answer it. So thank you very much for the question. Now about the pump stations, for us it's a dirty work, just like because it's only the pump station where you have all the clogging and you have all the sedimentation inside the tank, and this is the reality. And wastewater treatment, definitely you treat it and you get a good thing about it, and this is really good. Like in Jordan, 215 million cubic meter per year are treated and used in agriculture, which is really valuable. Yeah, so we don't underestimate the wastewater, but for the lifting station, collecting a lifting station, it is only the transport process where it's really dirty, you know. So this is first thing. Second thing about the industry, okay, industrial application. Now we use in the collection tank and all polyethylene high density, which have a very high resistance, even let's say to water where it's very, let's say, abrasive and this kind of thing. But if you have chemicals which, let's say, induce, let's say, a very high corrosive application there, maybe it could be going to, let's say, the collection tank and pipe network into more, let's say, resistant material, like in a metallic duplex or super duplex. It is only the piping and the, let's say, collection tank. This is also doable, but from our experience and the experiments, like the polyethylene high density, PEHD, and sometimes the LD, the low density also, is the most suitable for such application in sewage. Industrial special chemicals, this is a different story. There were another question, remind me about.
Yes, it's the same. It's the whole system is just to give more life to the pumps. As all the wastewater would be flushed again back to the
Yes,
system.
we don't treat water, we just collect it and transport it. So the system, the advantage of it, it's the shutdown, the clogging. You have a clog-free operation, a very reliable operation, and also you save energy from reducing the ball passage of the pumps. Yeah? I hope I answered your question. Hopefully. Yeah, thank you.
Thank you. Last question, please, from here.
Thank you for all speakers. I have one question for Willow and one question for Paul. Let's start with Willow. Actually, I want to emphasize on that our session is on advancing technologies, but we have, let's say, a dilemma in Jordan, from my personal perspective, that we need to solve the basics, then jump into the advancing technology. For example, we have a pilot in northern Governorate. We take let's say, selective facilities for pumping. Maybe Tamer also was with us. Out of maybe 70 pumping facilities, we found that more than 78 of them working outside the performance curve. Why? Because simply when they are selecting pump, they are selecting with ignoring the system curve, only relying on the performance curve. This is typically in Jordan, and we keep inform them, you need to select on the intersection between both curves. They are insisting that you only just have the flow and pressure and then make a duty point, because when we are talking about pumps, we are talking about curves, not points. This is at the first level. For Paul, he present a different solution for pressure management. Also, my question is how you imagine that pressure management could be implemented in the intermittent water supply regions. In Jordan,
I already asked this,
okay.
You missed it.
Okay.
You missed it. He answered that.
Because I think in Jordan we are under special conditions, so operationally we have alternatives.
Yes, we address this. For your second question, Mahmoud, but engineer Khalduni want to
It's
comment on
only
that.
one word. It's not only the bumps out of the curve, all Yarmouk is working out.
No, I tell you, fun. Actually, no. Actually, it's not. Just to tell you something, like sometimes it is really funny to say that, but unfortunately this is the case in Jordan, and many stations you delivered it and the pump are, let's say, running outside the curve, or let's say tripping at the first. Even with variable speed drives, you cannot adapt because the system curves have different demand. Sometimes let's say recently now, I don't want to speak about the project name, but we have supplied like more than 9 pumps of big capacity, like 350 kilowatt. This is not very big, but let's say medium to big, and 400 kilowatt pumps, 9 pumps to one station. And then the pumps reached the site, and then they discovered that there is more water coming into this pump station. Like it was 600 cubic meter, now it is increased to 1,000 cubic meter, the source. And they need to keep those pumps. Now they need to replace to a bigger pumps to adapt. And this is when they receive the new pumps. And always we face this, so we always tell the first point in optimization is to adapt to duty point and really work on something physical. If you are in rehabilitation, you can go there and do the measurement at the site, see your demand, forecast the future demand of the station, connections or whatsoever, and then you can select the pump or the pump stations in a way which you can adapt. So you can divide the duty into parallel pumps in operation rather than bringing a big pump. You can break it down into, let's say, 3 in parallel instead of 1. So you can get the full demand, definitely, but you will not have a trip if you have very low demand, for example. So yeah, first point is to adapt the requirement, to really know the requirements there, or at least, let's say, to better select the pump systems to suit it in case of any deviations.
Thank you, Mohammed. Before thanking everybody, I would like to have one quick comment. As I said, use advanced technology or solutions is always a challenge when you have to sustain them and utilize them. What I like about both solutions from Willow, sustaining lifting a station is an issue and maintaining that. Their system come up with a creative approach to maintain itself by itself, which is you don't need to have the human being maintaining, cleaning the lifting station. This is helping because we have some laziness in our utilities to do their job. So this actually covers the sustainability issue with having the right size,
more efficiency,
self-cleaning, less reliance on a human being. That's an interesting one. And when it would come to utilization, which is also another challenge, with POD system, they start introducing the AI, and I actually personally use that. You don't use the people to manage the system and optimize it correctly when you have the AI and the learning modules. They have a learning modules, and if you activate that, you really can manage the DMA in a more optimized way without the interference of human being. So technology is going there to address these two, in my opinion, key issues in using technologies is sustainability and utilizations. So thank you both for your innovations, and thank you everybody for
I
attending.
would like to thank you, Tamer, and it was a good decision of us that you will be nominating.